So in this video, we're going to learn about integration methods, and more so I'll list them. So the first one is integration by parts. So this borrows a lot from chain rule. And then the second method that we have is integration by U-Substitution. This is the one that I'll tackle today. Then the third method that we have is integration by fractional decomposition. So the other ones, I mean, they are common methods. These are the most complicated ones. We normally, I think this is, and then we have trigonometric ratios along the way that we need to understand the rules. But allow me today teach you integration by U-Substitution. So I'll proceed and say, so we start by integration by U-Substitution. So what exactly is this? So normally they'll give you a question like integrate, I mean, it's an indefinite integral, so there are no limits, that is a, b. They tell you integrate the square root of perhaps maybe e power x, the square root of e, or 2e power x plus 5. So what is the most important thing that you need to learn in U-Substitution? So tips is that always look at something that when differentiated, you will always be able to get something close to what you have that you never substituted for or u. For instance, if we take what is inside here, then we decide to differentiate it. Do we get something close to e power x? Do we? If that is the case, then that makes the whole integration very simple. So let me share an example. So let me first, okay, before I share the example, let me just show the general rules on how this is done. So when given integration f of x, perhaps g of x, and then we say let so perhaps we say let, okay, but before we say let, normally all this is in regards to what? dx. Yeah, so if we say let g of x be u, then d of dx of g of x should be something close to a factor of f of x, or makes it simpler to solve to simplify f of x. Things to remember: what you need to remember is that at all times you should not have a function of x after substitution. So never, so tip number one is never have a function of x after substitution. That's one thing you need to remember. So once you replace, okay, for instance, if you replace something here, you've said u is this one, so you replace du over dx, you know, I mean, differentiate that. When you do the replacement here, always ensure that you do not have anything that is a function of x on the integral. Yeah, so without much ado, so let me just screenshot this. Yeah. So now let's take these questions to our whiteboard where we will be discussing it. So an example. So let's put this here. Yeah. Now we are supposed to solve. Let me just zoom this out. So we are supposed to solve these using U-substitution. So let's solve the first question. So using U-substitution, so f of x equals to 3x plus 7, then power 4. That implies that the integration of f of x, which is 3x plus 7 power 4 in respect to x, will be given by first of all, we need to identify what is our u. So normally when there's a bracket, that is normally a tip. It is a question that has been simplified. Whenever you have a bracket, ensure that whatever is in the bracket or under a square root is the one that is converted, is the one that is equated to u. So in this case, whatever we have in the bracket is 3x plus 7. So we say let u be 3x plus 7. So that goes without saying that du over dx will be given by the differentiation of 3x plus 7, which is what? Which is 3. So now let's split this and say, so that implies therefore that okay, du over dx equals to 3, meaning if you multiply both sides by dx, this implies that du equals to 3 dx. We want to be left with dx alone. Divide by 3. This implies that dx equals to du over 3. Then, so we already have a replacement here. So let's go back to what we have in the question. Let's move forward. Let's see. So therefore, let me see. So therefore, we say now substitute. Sorry, let me just delete this. So changing my pen. So therefore, substitute for u equals to 3x plus 7 and dx equals to du over 3 in the question to get, what do we get if we substitute? So remember, we have our 3x plus 7, which is our u now, and then we have our dx as well, which is du over 3. So let's solve that. So this will give us, let me just split this. So the new integration will be the integration of u power 4. Remember, okay, just simplify that. So this will give us u power 4 multiplied by dx, which is now du over 3, which can further be written as 1 over 3. We are taking this 3 outside with the fraction here. Integration of u power 4 du. So solution. So therefore, now we have something simple that we can do with direct integration. So therefore, the integration of u power 4 in respect to u will be u power 4 plus 1 divided by 4 plus 1, then plus c. This is the integration in respect to u, but remember we said but u equals to 3x plus 7. So this means that the final integration will be 3x plus 7 power, what is 4 plus 1? That is 5, divided by 5, then plus c. And this is the answer. Simple, nothing complicated. That is the first example. Let's go to the second example. Remember we had this, so let me go back to what I had again. So let's clear this. So now we solve the second question and say that we've been given the integration of 3x square root of x squared minus 5 in. So solution. So as I said, anything in a bracket or anything under a square root, it is simple. You pick that and sacrifice it to be the u. So therefore u will be x squared minus 5. Just delete this. X squared minus 5, which goes without saying that du over dx will be the same as the differentiation for this will be 2x, I think 2 minus 1 x, so this is 2x, which implies therefore that dx will be the same as du over 2x. Yeah, so we substitute this whatever we got here back into the equation. So this will give us so therefore our new integration will be 3x square root of u multiplied by what is our dx now? It is du over 2x. Then you know this goes without saying that x cancels by x1, so we have 3 over 2 left, which means that therefore that now we have 3 over 2 integration of u, the square root of u is the same as u power a half, then du. And this goes without saying that now that we have something we can solve quickly. So the integration of u is u power half will be u a half plus 1 over a half plus 1 then plus c, which means therefore that now we have u, which is u a half plus 1, that is 3 over 2, so it's u power 3 over 2 divided by 3 over 2. So 1 divided by 3 over 2 is the same as 2 over 3 then plus c, which means therefore if we replace the value of u with x squared plus what? Let me see. We said u to be x squared minus 5. So therefore, if we replace that with what we have, we will get 2 over 3. What is our u? It's x squared minus 5, then power 3 over 2 divided by, not divided by, but plus c. So this is how you solve by use of integration by parts. By U-substitution, sorry. So this is simple, nothing complicated. We'll do the final example, not really final example, but the final question in the what I posted. Let me see. So let me try and solve this. So we have solved the first two. So let's solve this, the third one that looks a little bit scary. So we've been given number 3. We've been given the question as the integration of sec squared x sec x squared, that is how it's supposed to be read, then tan x dx. So this this is a question that requires some knowledge of trigonometry and integration and differentiation. So for you to solve this, you need to see which one dissolves fast, which one, if I attack it, will surrender fast. That is the principle of solving something complicated. If you want to beat 10 people, beat one that is holding the crowd together, the rest will just surrender. So let's start by saying, so let U be, so which one can we simplify here? This one, if we integrate it, will give us something close to this. So let U be sec squared x. Actually, not sec squared x, but sec x. Sorry. Okay. What am I doing? Yes. So let U be sec x. This means, therefore, that du over dx will be, what is the differentiation of sec x? So the differentiation of sec x was given by sec x tan x. So as I said before, you need to understand the trigonometry in its entirety because they borrow from each other. Differentiation borrows from integration, integration borrows from differentiation. So now that we have this, so what is our d? What is our dx? We need to make dx subject. How do you make that? So let me remove this this photo. I don't need this. Now we no longer need it because I want to do the other examples. You feel free to pause the video and do them and try to see if you've understood anything. So this therefore means that dx is given by du over sec x tan x. And this goes without saying. Now we're supposed to replace this into the original equation to have, this is the integration of what is our sec. So sec squared x will be the same as u squared multiplied by tan x. But what is our dx now this time around is du over sec x tan. And this we cancels out. And remember, sec x is again what? Is u. So we're supposed to now, this gives us this is integration of, let me just add this, and I need to clear some things here. Yeah. Let me see if we can clear this just to get some space. Yeah. Okay. Back to this. So that this means therefore that so we can replace this and say this can be rewritten as the integration of u squared multiplied by du divided by what? By u. Because as we said, u should be sec x. Then by u1, by u, this can have u alone. So this will be rewritten as integration of u du, which is u, this is power 1 plus 1 divided by 1 plus 1, then plus c. So let's move on and say, okay, I'm getting a lot of stuff together here. Let me try and delete some stuff here. We don't need this. This is already understood. Yeah. So this means that now we have our new question as u squared plus c, but of course u squared divided by what? By 2. But remember, u equals to sec x. So this, if we substitute, and if we replace by where there is u, we put sec x, we get sec x squared divided by 2, then plus c. But the right way to write this is not how you write it. The right way to write it is to say This is sec, this is equals to sec squared x divided by 2 plus plus what is going on here? Yeah, so plus c, or a half sec squared x plus c. And this is how you do integration by U-substitution. Let me know if you have any other question. If not, try to pause the video. You have the screenshot for the question. I can actually also repost. I can actually repost the same question here, the same screenshot here. I can do that, so that at least you guys are able to. Okay, let me see. I think here this is okay. So this is the, feel free to pause the video, then do the question. Let me just zoom out. You can get to see the question. So try to solve number 4 and 5 and let me know what you get as your answer on the comment section. If I see there's a challenge, then I'll solve the question and get back and I'm going to provide the answer.